The objective of the experiment was to determine the time that it takes for the oil and the water to switch in order to know the time of the hourglass. In order to determine the time of the hourglass, we used Torricelli's draining equation in order to know the velocity at which the water was exiting the bottom part of the water of the hourglass. After getting the velocity from the Torricelli's equation, we used it in the volumetric flow equation in order to clear for the time and get the time that the hourglass will be. Torricelli's equation tells us that if we have a water tank and the area 1 is very large compared to the area 2, then the velocity at which it drains at the area 1 will be almost zero compared to the velocity at which it is exiting from the tank. Both pressures of both parts of the Torricelli system had the same pressure which was at the atmospheric pressure, and since the hole in the part 2 was at the bottom of the system we were analyzing, it was cancelled due that it was zero in height.
Two water bottles with their caps, water, oil, colorant, straw, drill, scissors, silicone gun, and silicone and straw. To start, the silicone gun is used to put together the two bottle tops from the upper part. Then, using the drill and scissors, two small holes are formed on glue parts by size. After that, the scissors are used to cut the straw in half. When the previous step is done, each half of the straw are stuck inside the holes of the bottle tops in order to one of the halves to be greater in altitude on one side than the other. The same is done in the other side. Cover the holes in silicone so they are gripped and the straws remain firm. When the bottle tops with the straws are done, fill one of the bottles with water and add the colorant to it. Then fill the other bottle with oil almost at the top. After that, cover the bottle with oil using one of pastel bottle tops. Finally, carefully and without letting the water spill, cover the bottle with colored water with the outer glued bottle top. That wasn't used to cover the bottle of oil in a way that the bottle of colored water ends upside down over the bottle of the oil.
We measured the diameter of the straw to get the area from that, and then we inputted it in the volumetric flow equation, that is V times A. The result was 3.88 times 10 to the minus 5. To obtain the time, we used the same equation, that would be volume divided by volumetric flow, that it would be equals to 12.88 seconds. The real time it took for the water to switch in the experiment with the oil was about 45 minutes.
The principal reason why this project worked was because of the difference in density. Due to oil being less dense than water, water ended up being in the bottom of the hourglass and the oil on top. This is the reason why there were two holes in the bottle cap, so the water could get down in one hole and the oil could get up in the other one.
However, there were several reasons the results were diverse from the theoretical development. For instance, the theoretical time was 12.88 seconds, while the experiment one was 45 minutes. This is due to the fact that the fluids were not ideal. Also, the viscosity of the oil didn't let the water flow easily. Our volumetric flow wasn't constant. These are some of the reasons why our percentage error was so high. Our objective was accomplished. The liquids were successfully changed from position. The time could be measured because of it. However, there were several reasons the results were diverse from the theoretical development.
This video.
Thank you.
Thank you, Sammy.
Thank you.
We love you.